So the Gaussian elimination method, it basically just has 3 elementary operations which you can combine wisely to convert the system into the triangular shape. And these 3 operations, I will show them, actually 2 of them I will show, the other one it's less frequently needed, but still there's the third one as well. So if you look at the system like this, the Gaussian elimination method, basically it goes like this. First, well, when I look at the system like this, first I will suggest to swap the equations, because this equation seems a little bit simpler than the other 2. So if I take this one as the first equation, here it is, and if I just, well, the one with number 2 will go second, and the one with the number 3 will go third, is my first step in my Gaussian elimination method, and that shows you the first type of the operations which are available to you. It's called row swaps. Normally, if you want to record the steps which you take while doing your Gaussian elimination, you normally introduce these labels for your equations, R1, R2, R3, even though probably E1, E2, E3 will be better choice for the labels, because equation 1, equation 2, equation 3, but the usage of the letter R, I will justify this in a second. So at first stage, you see what I did? I just swapped the rows. So I swapped, and I record this. You may record this for your for the benefit of your exposition. Like this, you can say we just put the second row into the first position. We put the third row into the second position, and we put the first row into the third position. That is exactly what we did. We just take the records of this transformation. So it's the first type of the operation which is available to you. We just go row swap. Now the main operation which we'll use very heavily when you do the Gaussian elimination is which is called the row reduction operation. And well, basically I can demonstrate this right here. The row reduction operation allows you to vanish this term and vanish this term in one go. Because what I can do now, I can multiply the first equation by, say, -2. Well, it says here -3 because it's just a -2. I can multiply this first equation by -2, and I can add it to the second one. If I do this row reduction or equation reduction, then that will vanish the coefficient next to the x. Something will happen to the coefficient next to the y. I don't care about that. Something will happen to the right-hand side. My objective at this stage is to vanish this term, and if I do this operation, that will do the trick. So I keep my first equation. The second one will be, look at this, -2y plus -y, it's -3y. -2z plus z, it's -z, here it is. -8, -1, it's -9. If I now do the combination with 3, and this time I will add the equation to the third one, and the choice of -3, again, I think it's obvious, because that's the one which is needed to vanish this 3. That's the only reason why I choose -3 there. So I multiply this by -3, I add it to the third one, that will vanish this term. Something will happen to these two terms. Let's just see what happens to them. It will be -3 plus 2, it's -1. -3, -1, it's -4. And right-hand side, it is -12, right? -3 and 4. -12 and -2, -14. Here it is. So this stage, it's the row reduction stage. And if you would like to record this for the benefit of your exposition, I'll record this for the benefit of my exposition, and I'll let you. And I'll let you ask a question. This is called the row reduction or equation reduction. And if I record this, here's a recording of what happened. Here, at first, I took the first row and subtracted double of that row from the row number 2, and I put it back into the row 2. That was the elementary operation I did, which resulted in this better equation. And another elementary one which I did was this one. I tripled the row 1, subtracted it from the result of that from the row 3, and put it back in the row 3 right now. Now, so if I want to convert the system to the triangular shape, I have to get rid of either this y or this y. Probably reading of this term will be easier because it is, I mean, using this term and using this term reading of this one will be easier. So probably I'll need another row swap. Yeah, I do need, I just made another row swap, so it's my first equation. My third one went into the second position. Obviously the second one went into the third position. Is my new system after another row swap. And if I now do another row reduction with the coefficient -3 again, and I think again the choice of a -3 is obvious because it's a -3 coefficient will help me to get rid of this -3. If I multiply this equation by -3 and add this to the last one, so if I do the recordings of what I'm intended to do right now, if I do something like this, my system will finally come to, let me just put it up a little bit. My system will finally come to the triangular shape. Here's the first equation. Here's the second equation. Here's the last one. And that's a system which in principle can be back substituted now, the way I back substituted the other system. I'm not going to do it right now. It is not my intention to make you do lots of computations.